Let us look at another example of decision tree learning. Here is a data set of people who go to the beach, and some of them get sunburned and others don't. In this data set, there are 9 examples, and each example is characterized by 4 features: hair, height, age, and lotion. Once again, how can we construct an optimal decision tree that will classify all of those examples? One possibility is to discriminate first on hair color. Hair color classifies all of these 9 examples into 3 categories: brown, red, and blonde. The interesting thing about the choice of hair color is that in case of brown, all the sunburn cases are negative. People with brown hair apparently don't get sunburn. In case of all the red-haired people, there is sunburn. So hair color is a good choice for picking as the feature to discriminate on, because it classifies things in such a way that some of the categories have only negative instances and no positive instances, and some of the categories have only positive instances and no negative instances. Of course, that still leaves blonde-haired people. In this case, there are both some positive instances and some negative instances, and therefore we need another feature to discriminate between the positive and the negative instances. Here, lotion might be the second feature that we pick. Lotion now classifies the remaining examples into 2 categories. Some people used lotion, other people did not. Those who used lotion did not get sunburn. Those who did not use lotion did get sunburn. Once again, these are all negative instances. These are consisting of only positive instances. Thus, in this decision tree, simply by using 2 features, we were able to classify all of these 9 examples. This is a different decision tree for the same data set. But because we used a different order, therefore, now we have to do more work. This decision tree is less optimal than the previous one. We could have chosen a different set of features in a different order. Perhaps we could first discriminate on height, and then on hair color and age. In this case, we get a much bushier tree. Clearly, this tree is less optimal than this one. Note the trade-off between decision tree learning and discrimination tree learning that we covered in case-based reasoning. Decision tree learning leads to more optimal classification trees, but there is a requirement. You need all the examples right up front. Discrimination tree learning may lead to suboptimal trees, but you can learn incrementally.